connection of electrical components. Okay, now, of course, what are the electrical components? Before I talk about it, I'd like to tell you what is the purpose of a circuit, right? Before we learn anything, we need to know the purpose. A circuit is used to manipulate electrical signal. Yeah? The purpose is to manipulate. Is that right? Okay, just look at
Oh my God.
Okay, then you get more questions, right? What are electrical signals? Well, the music you hear composes of electrical signals. Okay? And the electrical signal is basically made of voltage and the current. Yeah? Okay? Voltage and the current. You know what's a voltage? You learn from physics, right? You know what's a voltage, what's a current, huh? Have you?
No.
No?
No.
It was not high in physics? Wow. So every time I write something, I have more questions. Huh? See, that's the difficulty of teaching this class, because basically you have very little background. So everything is new for you. See? If I taught a senior level, then they have the background and they just get into the lecture right away. Okay. Why do we have voltage? Actually, when you say voltage, it is called the potential. Okay? Now, when I put something up here, we have what we call the, what type of potential? Huh? Yeah, position potential, right? Because if you let it go, it will drop, right? For the electrical potential, which is called the voltage, it is because in one place you have a lot of charge. Okay, you know what's charge, right? I hope I don't explain what's charge, right? Okay, now charge has two types of charges, right? The positive charge and the negative charge. Okay, now, so in one place you have a lot of charge, and in another place you have very little or no charge. Then this would create a potential difference, because the place that has a lot of charge would have a high electrical potential. Yes? Okay, the place that has no charge has zero potential. So therefore, you can see there's a potential difference between the two places. Yeah? Got it? It's very much like the water. Huh? If you have a reservoir, you have lots of water, right? You have somewhere that has no water, and then there's a potential, right? Okay. Then the current, it is directly related to the electrical potential. Why? Let's say you have water, right? You have a tank of water here. You have no water here. If you open up the gate, or you drill a hole, what happens? The water starts to flow, right? And the water starts to flow is because we have a higher potential here, we have a low potential here. Yeah? The same concept for the electrical current, okay? Because when you have a lot of charge on one place, you have no charge on the other place, and then if I somehow connect the two, then the charge will start to flow from the higher potential to what? To the lower potential. And that flow of charge is called current. Simple, right? Okay, now, as I mentioned, in order to have the current flow, you must have lots of charge on one end. You have no charge on the side, right? And also you need a conductor, right? Okay. Now for the water to flow, all you need is just a pipe, right? But for the charge to flow, you have to use a material that is conductive. Got it? You cannot use an instant because the charge cannot flow in an instant. It got to be a metal. Yes? Okay. So that's the concept of the voltage and the current. Now when you have voltage and current, then you can have what we call the power. Okay? Because these two can also give you what we call the electrical power. Okay, we heard about power, right? Because let's say we have a stereo system, right? At the end of the stereo system, we say what is the output power, right? And the output power will decide on what? Decide on what is the volume from the speaker. Huh? The larger the power, the higher the more volume out of the speaker. Yeah? Okay, now, let's go back to here. Why do we have to manipulate the signal?
Too much overheat whatever circuit is going through.
That's a more, that's a lower level. You have to go to a higher level. You like to listen to music, right? You like to watch the TV. You want to use the iPod. Yes? All these are what we call the electronic systems. Yes? Got it, system, okay? A system consists of many, many circuits. Got it? Okay, so a system is a bunch of circuits. Okay, so when you want to listen to the music, right, you know what the radio station do, right? There's a tower, right? Have you seen the tower, radio tower, right? Okay. The radio tower, what does that do? Huh? It transmits the signal. Yeah? Transmit the signal. So therefore, in the environment, we have many, many different signals. We have radio signal, we have the Wi-Fi signal, we have the phone signal. I don't know how many. Okay. Now the question is, how can you capture, read, and watch these signals? Can your ear capture the signal? Can your eyes just watch into the air? Can you see the video? No, right? If you could, why don't you listen? So therefore, the purpose of our system is to capture all the signals available in our life. Yeah? Okay, now let's go to something very simple. Let's say you have an iPod, right? You listen to the music. The music, as I said, was transmitted from a radio station, right? Okay. But, you know, when they transmit a signal, they do not transmit directly the music signal. If you are majoring in electrical engineering, later you're going to learn a class called communication. And in the communication, you will learn how can the radio signal be transmitted and be received. Okay? So, how do they transmit a song into the air? If they just transmit a song without anything else, then the signal will not be able to transmit within a few meters because of the nature of the signal. Of course, you cannot say I will stay near the tower within a few meters, right? You don't want to listen to my music, right? You want to listen everywhere, like at least within a few miles, correct? with a carrier signal. Carrier. It's like you want to go from here to this, right? You walk too slow. So what do? You have to sit in the car, right? The same concept, okay? In order to transmit the music to a long distance so that you can capture, you need to have a carrier signal. So the music signal will be carried on the carrier signal. The carrier signal is a one frequency signal. So when I say one frequency signal means when you hear it, it's like a one tone, got it? When you have one signal, the sound of that signal is one tone, okay? Now when I speak, I have multiple signals. So I have higher frequency and low frequency. The music is the same, right? Because the music, we have the human voice, we have the drum, we have the guitar, right? All these are different signals. Okay. So the first thing you have to do when you try to capture the music with a system is that you have to try to get rid of the carrier signal. Got it? Because carrier signal is not pleasant to listen, but it is used to carry the music to your device. Okay? And then, so that's one circuit you have to do. Right? The first circuit in the radio is to eliminate the carrier signal. And then the second step is to amplify the audio, the music, but with a reduced noise, because you don't want to hear the noise. And then the last stage is to make the signal even larger. So what? So it is audible, right? Because if the signal is too small, too low, it's not audible, right? So that's an example of why you need circuits, right? Because different circuits will do different things, and that at the end it will give you something you are looking for. Okay. So next time, let me get into the electrical components.